Introduction for the Atterberg limit. The Atterberg limit test is conducted to determine the liquid limit and plastic limit of the soil sample. These limits are used to evaluate the consistency and plasticity of fine grained soil. For standard proctor test, compaction is the process of reducing air voids in soil by mechanical means to increase its density. The compaction test is carried out to determine the optimal moisture content (OMC) and maximum dry density (MDD) of the soil. Objective: Atterberg limits to determine the plastic and liquid limit of soil. Number two, to compare the Atterberg limit values between untreated and treated soil. For standard proto, number one, to determine the compaction characteristic of soil sample. Number two, to compare the compaction characteristic of untreated and treated soil sample. Background of study. For Atterberg limits, the Atterberg limits test is used to determine the liquid limit and plastic limit of the soil. These properties indicate the soil consistency and plasticity. In this study, recycled wood sawdust was added to evaluate its effect on the Atterberg limits. And then, for standard proctor test, the standard proctor test is used to determine the optimum moisture content (OMC) and maximum dry density (MDD) of the soil. In this study, the test was conducted to investigate the effect of recycled wood sawdust on the soil compaction characteristic.
For the liquid limit test, a soil sample of 300 grams passing the 0.4 to 5 mm sieve, and then we will add the distilled water and mix until a homogeneous paste was formed. And then the soil paste was transferred into the cylinder cup, avoiding air entrapment, and the surface was level. Next, the cone was lowered until it just touched the soil surface and the initial dye gauge reading was recorded. The cone was released for 5 seconds and the penetration depth was recorded. The cone was cleaned and 2 additional penetration readings were taken at reading was kept below 0.5 mm. A moisture content sample of about 10 grams was collected from the penetrate area. The procedure was repeated at least 2 more times using different times content. The remaining 20 grams of soil was mixed with distilled water until it reached a raw level consistency. Next, the soil was rolled into a tray on a glass plate until it reached a diameter of about 3.2 mm. And then we take a data, 3 empty moisture cans were weighed and their weights and identification numbers were recorded. For standard proctor test, in about 3 kg of dry soil passing the 20 mm sieve was prepared. After that, the soil was placed at the plate and create a big hole at the center of the soil. Next, we will add water to achieve a moisture content of about 7%. After the water was added, we will mix the soil and water by using scraper and ensure the mix is well mixed. Next, the mold and base plate were cleaned, assembled, weighed, and the inside of the mold was greased before attaching the collar. The matured soil was remixed and compacted into 1000 ml mold in 3 equal layers. Each layer we need to blow 27 times using a rammer. For the first layer, we will blow 27 times using a rammer, and it's same for the second and third layer. and ensure the compacted cover all the area of the soil. After the compacted was done, we will remove the collar. There were excess soil. We will trim the excess soil by using a steel straight edge. After that, we will clean the base plate by using a brush and weight the mold that containing the compacted soil, and a representative soil was taken for moisture content determination. The procedure was repeated several times with gradually increasing water contents to determine the optimum moisture content (OMC) and maximum dry density (MDD). We are taking a second and third test by using a same procedure. Data for the second test were recorded, and data for the third test were recorded. After that, the soil will go into the oven and record the data for the 24 hours.
Summary of finding. For the atomic limit test, the untreated soil record a liquid limit of 69%, plastic limit of 41.40%, and plastic limit of 27.60%. After we add wood sawdust, the values decrease to 46.20% for liquid limit, 29.78 for plastic limit, and 16.42% for plasticity index. This result shows that the addition of wood sawdust reduces the plasticity characteristic of soil So the treated soil became less plastic and more stable compared to the untreated soil. For the standard of the test, the untreated soil record an optimum moisture content of 34% and maximum dry density of 1.36 gram cm cube. After treatment with wood sawdust, the OMC decreased to 17%, while the MDD increased to 1.40 gram cm cube. This indicates that the treated soil required less water for compaction and achieve a higher dry density compared to the untreated soil. The discussion, Attribute limit. Based on the attribute limit results, all values including the liquid limit, plastic limit and plasticity index decrease after the addition of wood sawdust. This is because wood sawdust is a non-plastic material which reduce the overall plasticity of the soil when mixed together. A lower plasticity index indicates that the soil is less susceptible to change in moisture content and has better stability. Therefore, the addition of wood sawdust improves the engineering properties of the soil by reducing its plastic behavior. Standard proctor test. For the standard proctor test, the OMC decreased from 34% to 70%, while the MDD increased from 1.36 gram cm cube to 1.40 gram cm cube. This means that the treated soil required less water to reach its maximum compaction level. At the same time, the increase in maximum dry density suggests that the soil particles were compacted more efficiently after the addition of wood sawdust. As a result, the treated soil achieved better compaction performance and improved density compared to the untreated soil. For the conclusion, the objective of this project was successfully achieved by comparing the properties of untreated soil and wood sawdust treated soil using the attribute limit test and standard water test. The results show that the addition of wood sawdust reduced the liquid limit, plastic limit, and plasticity index, indicating a reduction in soil plasticity. In addition, the standard water test results show a lower optimum moisture content and higher maximum dry density, which indicates better compaction characteristics. Overall, wood sawdust has the potential to be used as a sustainable and recycled material for soil improvement, as it can enhance soil stability and compaction performance.